Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. If there is a function f greater than 0 such that fx plus y is equal to fx multiplied by fy for all positive integers x and y, and given f23 is 4 times f21, what is the value of f1 plus f2 plus f3 and all the way till f10? And this is a multiple choice question, so we have 5 options and we have to pick the right choice. So for solving this problem, we have a function that's defined, and a function usually, it states the rules of how a certain set of variables are mapped onto its space. But the unique thing about the way this function is given or defined, it's kind of a recursive definition, because in the definition of the function itself is invoked, right? So fx plus y is equal to fx multiplied by fy. So this is a generic rule that should be true for all positive integers x and y. So we can just substitute x equal to 1, y equal to 1, and basically we try to see how the function f turns out to be for the simple integer values like 1, 2, 3. Basically trying to see if there is some pattern that we can detect, because whenever you have a recursive definition like this, it's often based on some kind of a repeating pattern, and it's important to be able to spot that pattern in order to solve the problem. So what will be f2? So f2 we can break down 2 as 1 plus 1, and going by this rule, f1 plus 1 is equal to f1 multiplied by f1. So we basically have f2 is equal to f1 whole square. So what about f3? Well, we can similarly write f3 is equal to f2 plus 1, and then f2 plus 1 is f2 multiplied by f1. And from the previous step, if you substitute f2 equal to f1 square, we basically get f1 square multiplied by f1, and that turns out to be f1 whole to the power 3. And in a similar way, we can show that f4 is basically f1 whole to the power 4. So by now, we're able to convince ourselves that f of n takes the form f1 whole to the power n. So what do we do from here? Well, we now go to the second relationship that's given in the problem between f23 and f21. So what would be f23 according to this rule? Well, f23, according to the rule that we just derived, would be basically f1 whole to the power 23. And what would be f21? f21 will be f1 whole to the power 21. And then we simply write the equation that we're given. So that becomes f1 whole to the power 23 is 4 times f1 whole to the power 21. And then if we divide both sides by f1 whole to the power 21, on the left hand side we basically have f1 square, and on the right hand side we're left with 4. So f1 square is equal to 4, and from this we obtain f1 is equal to 2. So we can ignore the negative square root, because the function f is defined to be positive. So once we have f1 equal to 2, now we go back to the generic definition of Fn, which we obtained earlier, right? So that makes Fn is equal to 2 to the power n. Now we can actually find the sum of the series that we're given, which is f1 plus f2 all the way till f10. And if we write it out in terms of the exponents of 2, this will become 2 to the power 1 plus 2 square and all the way through 2 to the power 10. Now this series is a geometric progression. So the first term is 2 and the common ratio is also 2. And here we can apply the formula for the sum of a GP series, which is simply a multiplied by r to the power n minus 1 within parentheses on the numerator, and then in the denominator we have r minus 1, where a is the first term and r is the common ratio. So here the first term is 2, the common ratio is also 2, so that makes this particular sum equal to 2 multiplied by 2 to the power 10 minus 1, and in the denominator we have 2 minus 1, which is 1, and then if we calculate this comes as 2046. So the correct choice will be option D, 2046.